Okay, so starting off with our image production, this is a really large section. There's 51 total questions on the registry on just image production. Now that does include image acquisition and evaluation and equipment operation and quality assurance, 26 and 25 questions respectively in each of those two categories. It's a lot of questions on there out of the 230, right? Yeah. So do we need to really understand this concept or these concepts that we're going to talk about? Okay. So I gave you guys a copy of the ARRT content specs, and the very first thing in the image production section was this chart. I have not altered it at all. I did scratch out things in your book. The majority of this is taken from the end of chapter 6, pages 166 and 167 in your image production book. You guys, you know that chart. It does give you the arrows, doesn't it?
Yeah. Chapter 6.
Yep, page 166 and 167. So let's start at the very top with some basic definitions, because doesn't that help us understand what we're answering? What is receptor exposure?
The exposure of the receptor.
It's in the name, right? Are we counting how many X-rays reach the IR? Receptor exposure, it's all, well, there's beam quantity, beam intensity, which can equal or be related directly proportional to our receptor exposures. But it's just the number of photons reaching our IR, right? You guys have numbers that express that we're supposed to be paying attention to. Agreed? Okay. How about spatial resolution?
How clear the image is.
Okay.
Sharp.
There we go. I told you all to substitute some words for that make sense in our sharpness or accuracy, right? Do you remember the other terms that aren't actually in your image production book that we talked about? Started with a U. Durango?
I remember the word
Umbra. Umbra.
I remember penumbra.
Penumbra versus umbra. Umbra is a shorter word, right? Sharp,
Sure.
pretty short word. Unsharpness is a longer word. Penumbra, is that also a longer word?
Mm-hmm.
Can we keep...
Professor Umbridge is sharp. If you're a Potter fan.
Sure. Love it. Just throwing that out there just as a reminder. Spatial resolution, substitute sharpness or accuracy. And so that leaves distortion, right? The inaccurate representation of, we've got two types. What are they?
Shape and size.
Mm-hmm. We talked about that on Friday. And we found a new way to remember. I told my husband and he's like, oh my gosh. I was like, I asked them not to report me. I also told them not to say where they heard that from. You came up with it yourself. Congratulations. All right, you guys feel good about that? All right, so let's start at the top. No, it doesn't, guys. No, it doesn't. All right, mass. What does that affect?
Time. Receptor exposure. Receptor.
Of the three categories here.
Receptor exposure.
Only a exposure, yeah. It
Yep.
doesn't affect anything else.
Does not
Oh, it's
affect
X's?
on this particular one, but we're going to go over all of the ups and downs today, for sure. But I feel like you guys could do this. If we increase mass, what happens to IR exposure, right?
It increases.
It increases, so you should have an up arrow, right? Do you understand that mass doesn't change the sharpness or accuracy? or distortion? Does it change the size or shape? Does it help whenever you remember what those definitions are and you ask yourself those questions? That's what I want you to do when you're reading mock questions, practice test questions, and on the registry. You guys okay with that? What about KVP? Which one does it affect, or which ones?
Receptor exposure.
Does it change sharpness or accuracy or distortion?
Nope.
It does not. How about OID?
Increases distortion, well, affects distortion.
It does. It does increase distortion, right? And if it's distorted, can it be accurate? No. So, can I tell you a hint? A big hint, and we've talked about it before, and we'll talk about it again. If it's distorted, can it be accurate?
No.
So, these two are always going to be together. Now, spatial resolution doesn't always affect distortion, but it always works in reverse. If it's distorted, it can't be accurate. But it can be sharp or unsharp, but not distorted. Like motion. It can be blurry, but it might not, well, I don't know if that's a really good definition, but it didn't change size or shape. It was just blurry. You guys okay with that? All right, SID.
There's decrease in receptor exposure,
Receptor exposure, absolutely.
spatial resolution. Increase, and then decrease distortion.
Why do we do a chest at 72, right?
Yeah.
To decrease magnification. So if we're changing distortion or affecting distortion, don't we also change spatial resolution? Make it more accurate? Yes. Very good. I skipped one thing. So if you guys are looking at page 166 or 167, in your book, I told you last year to scratch out something with OID. Your book said that it did affect IR exposure. ARRT says it does not. So.
Oh, protein.
Agree on that, but.
We'll write it in on the question.
We're taking the ARRT test, and if they said it doesn't, I'm going to go with what they said. Again, I did not modify this as their chart. So I'm calling your book out for being wrong there. Okay.
If you're writing email.
I have some peeps on the inside I can argue with. Focal spot size.
Decrease on spatial resolution only. I mean, wait, focus on that, yeah.
So it does not change IR exposure, right? Does it change the size or shape of the body part on the image? No. So this is that example that I gave you that spatial resolution doesn't always affect distortion, but distortion always affects spatial resolution. Okay? Because focal spot size gives us the blur with our line focus principle, right? Okay. How about grids?
Receptor exposure.
It definitely changes the number of photons reaching our IR, right? Does it change spatial resolution or distortion?
No.
Does not. Contrast, yeah. But they took that column off because the lookup table controls contrast in digital imaging now. So. Like 2017 was the last time they had that on the content specs.
Tear it
I would understand it.
out. Tear it out.
Oh.
I shouldn't draw big lines or.
No, no, no.
You brought your book?
This is amazing. Okay, guys, Jay brought his book and he opened it. And he put it away. All right, moving on, tube filtration.
Took almost 2 years.
I'll try to see on the paper.
Receptor exposure, right?
You expose to yourself.
Does it change the sharpness, accuracy, or size or shape?
Heck
No.
No, does not. You hush. I didn't eat my breakfast this morning. Talking to me. How about beam restriction? What's another word for that?
Collimation.
Collimation.
Receptor exposure.
If y'all didn't say receptor exposure, I'd be very disappointed. Does it change spatial resolution
No.
or size or shape?
It's
No.
tempting to think that it affects spatial resolution at first, but
It doesn't make it blurrier
no.
or sharper.
Yeah.
It doesn't make it more or less accurate. It does affect contrast because of the scatter amounts. We need to understand that. Yes, scatter bad. But it doesn't change spatial resolution. So I heard something at the Kettering seminar last year that resonated with me to help you guys understand contrast is different than spatial resolution. So foggy morning, right? We can't really see if it's a red light or green light, right? Because the fog makes it too hard to see. Is that light still there?
Yes.
Is it still accurate?
No.
Yes. It is still showing a red light or a green light, whether or not we can see it because of the gray. So contrast doesn't change that. The fog in the air doesn't change that. That light is still there. So same with our image. The body part is still on the image, even if it's gray, but it still would be sharp or accurate. It's not distorted or blurry. It's just hard to see because of the contrast. So while they work together to make it where we can't see very well, they are separate. And they don't affect each other. Okay? All right, how about motion? Does that change technically the number of photons in our reaching our IR?
No.
Probably.
They're still gonna reach.
The ARRT says it does not. Does it change how sharp our image looks?
Yes.
Yes.
Because it's blurry if it's motiony, right?
Decreased.
Yes. Did that change size or shape?
No.
No. So again, another example where it affects spatial resolution but not distortion. Now I know you can argue that, well, what if they rolled? Then now you have an oblique part.
That's around.
That's not, you're going down a rabbit hole. Think about breathing. Just breathing. It didn't change the shape of the body part, okay? Per the ARRT. They gave us this. This is so nice of them to tell you the correct answers. All right, how about our anode heel effect? Receptor exposure. Which side has more photons on it?
That cat side.
Fat cat, yeah, very good. Does it change how sharp or accurate the image is? Or the size or shape of the image? ARRT says it does not. So we've got some patient factors that we need to be mindful of. Size of the patient, so thick versus a thin patient, and different pathologies. Additive versus destructive pathologies. They didn't break them out. They included them all together here, but do you think that it would be important for us to know those? Okay. So I gave you guys an extra practice assignment for the additive versus destructive pathologies, but you can drag and drop in the correct box. The Kettering seminar this week will give you a book, and they have a whole chart of those two. Your textbooks have had them in there, we've talked about, but it's nice to have them all in one spot. So do patient factors affect IR exposure?
Yeah.
Yes. Can they affect the sharpness or accuracy?
Oh yeah. Yes.
Can they affect the size or shape of the body part? Can I explain a why there?
Please.
If you're not understanding how it's all three. So because they put them all together, I want to talk about just size. A thick patient, if we're doing a KUB, I want you to picture where their kidneys are on a thin patient. Are they closer to the table?
Yeah.
Yes.
A thick patient, do you think that they have more adipose tissue
Yep.
in the back? Are their kidneys the same distance away from the table?
No.
So we have more OID, right? Does that make sense? Okay. And we said if it affects size or shape,
Distortion.
it'll affect spatial resolution too, right? So it'll be a magnified kidney on our larger patients compared to a thinner patient. Technically. You okay with that? So if that patient, like a large patient, we'll say, because I love my 600-pound life, they had a KUB somehow. Maybe they went to the vet's office, like the large animal vet, and they did a KUB and they measured the kidney on that patient. And then they had that bariatric surgery, they lost all the weight, but maybe they're just prone to getting kidney stones. So years later, they're smaller, and they get a KUB again. Are their kidneys going to measure the same size as they did before?
No.
Because the OID changed, right? They won't have all that adipose tissue. So that would be an example of the same patient being two different sizes. They'll be like, hey, your kidneys shrank. Will it be a lot? No. But the concept is what I want you guys to think about. Does that make sense? Okay. All right, and our last one, angle, tube, part, or receptor.
All three.
Oh, I should have had you guys change this in your book too. So your book says that it changes IR exposure, but the ARRT says it does not.
Okay.
I can say that if you angle, don't we collimate to where the light's not off the board, or we recenter to where the light's not off the board? So did we really change how many photons reached it if we angled our central ray?
So
If you rotated the body part, if like for a wrist,
OID.
OID, but OID doesn't change IR exposure either. If we angled the image receptor underneath the patient, all the photons are still reaching the IR. As long as we didn't have the light off the IR from some angle, they're still all going to reach the IR.
so it's just rain, like shower of rain, it'll still reach.
Mm-hmm.
Okay. Are we scribbling that out in the book?
I would, because the ARRT does not put an X in that column.
Does this mean they won't ask about the air gap technique?
They do have that specifically.
Doesn't make any sense.
So we're not counting on the scatter
Mm-hmm.
as wanted IR exposure.
I see.
I know.
Interesting.
Because we could use a grid to get rid of that same scatter from reaching the IR. So it didn't change, whether we used a grid or an air gap.
Mm-hmm.
I know. So if we angle the tube, the body part, or the receptor, did it change the sharpness or accuracy?
Yeah.
It did. Do we understand why?
Because of no angle.
If we angled the central ray, the body part, or the receptor, which type of distortion did we cause? Shape distortion, either elongation or foreshortening, right? And we said if we cause distortion, does it affect spatial resolution? Yes, it does. Does that make sense? All right. So which parts were we really unsure of, or did you guys have a good idea of it all? We're going to cover them all, but should have 18 exits, right? I think that's how many I counted. Yeah, 18. Or arrows. Okay. You ready to go over the first step? We're going to go line by line. Or do you want to take a break?
Let's go.
Let's go! Are we ready? Woo! Okay. Do you remember what milliamperage is? Tube current, yeah. It is. Tube current is the electrons flowing from cathode to anode. Can they ever go backwards? No. How about exposure time?
How long?
Seconds. How long? How long the tube current is flowing for? Does that make sense? Bonus question. How do we get the electrons?
The electron cloud, heating up the filament.
Through the process called? How do we heat up the filament?
Electricity.
Yeah, very good. We applied current to the cathode filament, and the electrons were boiled off through thermionic emission. So the tube current and the exposure time, we multiply them together for mass. Yes. It is directly proportional to beam quantity. Don't let your brain gloss over that statement. Break it down. What does that mean? If we increase mass, what happens to the amount of X-rays in our beam?
It increases.
Which direction are your fingers both going? The same direction? What if we double one? What happens to the other? It also doubles. Is that proportional?
E.
So do we understand directly proportional? All right. What happens to quantity when we double our mass?
Increase.
How much?
Doubles.
Because that's what directly proportional. I was like, double proportion? That's not the word I was looking for. I had to look at it. Directly proportional means, right? We just said it. If we double the mass, we will double the quantity, which is the number of photons in our beam, because we're talking about beam quantity, right? So throughout these lessons, I'm going to be focusing on just one side, mostly increasing, right? However, you need to understand what happens when you decrease those factors too, which is why many of the questions on the key terms formulas sheet that I gave you are not what is on the screen. It is the opposite, because I'm trying to get you guys to think about it in both directions. Now, I'm a big fan of just knowing half the amount of information. If I understand it this way, I think I can figure it out the other way. I think you guys can too, but I just want to get that brain working. So don't write down exactly what's on the screen. Read the page. I don't want you studying the wrong thing. If you have questions, please let me know. All right, guys, if we increase the quantity of X-rays, what happens to the number of X-rays reaching the IR? By how much?
Exact same.
Oh, look, it's directly proportional as well. Everybody increases, right? What about if we skip the middleman? We skip the quantity part. If we increase our mass, what happens to IR exposure? It goes up, right? So that's why your arrow should be up on that one.
Are we supposed to be answering these like on our own as we go by?
You can.
Or are we
So-
gonna like for sure it's the right answer? Like what if we have?
Everything that's there is in here, or it's something that I'll either say or it's on the screen. So to keep you guys awake and engaged, I gave you a sheet. Some people don't want to be just listening. So it's an option for you whether you do it right now or later as a studying tool. So the same's true in reverse, right? Okay. Something to keep in mind is that mass is the direct controlling factor of receptor exposure, isn't it? I'm British today, isn't it? So notice the chain reaction here. Increased mass, increase the number of x-rays that we create in the tube, increase the number of x-rays reaching the patient, and then we increase the number of x-rays exiting the patient and reaching our IR. All of these are direct proportional relationships. Just by doubling mass, we double all of those other things. Starting with the number of electrons in our tube. You okay with that? What exposure time do orthostatic breathing techniques require?
A long exposure.
Long exposure. 3 to 5, I want to say, is like the textbook answer. But how do we get that?
Increase our time.
If we increased our time alone, would that increase our mass? What if we didn't want to increase our mass?
There's a formula for that.
Decrease MA.
Decreased MA, right? Oh, that's called the reciprocity law. So it would require a lower MA and longer exposure times if we were going to do an orthostatic breathing technique. Because we don't want to increase the total mass if we're using a breathing technique. If we wanted to keep the mass the same, it's required. Because they have an inverse proportional relationship, right? MA and time. Can you show your table partner what inverse looks like? No, that's not. Well, I guess so. No. All right, very good. What does proportional still mean? Same. Equally, but with the inverse, it's just in the opposite direction, right? So that concept is called reciprocity. If we double our MA, what would we have to do to time to keep the mass the same?
Have it.
Half it. We had to do the complete opposite, the equal amount in the other direction. You guys remember that? We've talked about it at least twice now in image production class alone. I know that the term reciprocity is nowhere in your image production book, but I do love that Clover has that quiz in the video on just that alone, and it is named reciprocity. How are we doing? Coming back, right?
Oh, yeah.
This is stuff we could use every day in clinicals.
Yeah.
Just at clinicals.
Where's that?
Anyway, when would we use the direct square law? Maintain.
Yeah.
When what's changing?
KD. Our mass.
Distant.
Distance. Yes. So we use the direct square law when we want to maintain our receptor exposure when we change distance because of the inverse square law. If we go from 40 to 72, what happens to our light? It spreads out, right? And then we collimate to just the IR because we should not have light on the wall behind the patient. There's no need for that. So didn't we lower how many x-rays reach the IR? Would that cause a low DI number? The patient would be underexposed. So how do we put the x-rays back in the beam? Collimating? No. Increase our mass. Yes. So since increasing our SID reduces X-ray intensity, we have to increase our mass because that's our controlling property of how many X-rays are in the beam. So here's a good one. If you want to switch sheets with somebody and write the direct square law, bless you, on their paper, see if you're right. What is the direct square law?
There's nothing. I got it right here. So
She said to write it.
you do yours, I'll get check.
From memory, because it doesn't have to be in our brain.
Yeah, hold on.
I got it right.
What is it?
You did it.
Well, you read it.
You wrote direct square law.
The formula,
Oh, that's all.
not the words direct square law.
Obviously, 7 equals 0.
All right.
3 over 19.
Filling in the blanks already? Yeah.
Does the name tell you where to put everything and what to do?
Sort of. You don't flip it.
No, but it's not.
Don't flip
That's
Direct. Yes.
so 1 and 1, 2 and 2.
The inverse square law would be the number.
There's the opposites, so the numbers are opposite from the formula. It tells you.
I forgot.
We only flip one.
Square.
So it should look like that, whichever way you like to write it. I like to just use D because we can plug in any distance really. Whether you put the squared at the top or bottom, just make sure that you do actually square the top and bottom of the distances. So this formula helps you figure out how much your new mass should be increased in order to maintain the same exposure. What would happen if we increased our SID and we didn't change the mass to compensate? What's the name of what our image would look like? What would we see on it? Quantum noise, right? Yeah, it'd be grainy. You're like, oh, that's garbage. And then the opposite would be true as well, right? If we went from 72 to 40 and didn't lower the mass, bless you for your attempt. Wouldn't the patient have just received too much radiation unnecessarily? Would our DI number express that? It'd be high, right?
Hot.
Yes. And I heard you guys talking about it. Why is it called the direct square law? You guys did great over here. Because it's not indirect. Because if you increase SID, what do we have to do to the mass to keep the IR exposure the same? Increase. Oh, look, both your figures are going in the same direction. So that means both ones go on top. We do not flip the other side because they are direct in the same direction. Only the inverse square law would we flip the 1s and 2s. And what do you not want to forget to do? Square! That's why we always write the formula, right? Sometimes we will need a square root. Yeah. So the square part is still related to the distance, like length times width. Don't forget that the other name for the direct square law that doesn't tell you what to do is the exposure maintenance formula. Because we can't leave well enough alone. Let's do some math.
Oh, God.
Gotta have some practice in there. What do we remember? We just went over the formula, so I could have gave you this before we went over the formula.
Yeah.
So if you guys want, there's the back side of each sheet. It's blank if you want paper or a calculator.
If you have to get
Let's think about
What?
this. I got you. I got you.
You got this, guys.
Show your work, Jay. How'd you get there?
It's in my head, all the neurons.
That sickness just must have just
Down with the sickness.
It
Superpower.
made him smarter.
yeah, made you a math whiz.
Says he,
That shows all
his
for
head
you.
is disturbed because of all the sickness. If you know, you know.
Mm-hmm.
Tired of you.
Figured it
Now you're going to be able to do this on the registry, no problem, because you practiced enough, right?
That's right.
All right.
Always do the math, guys. Always.
I have a strong feeling Jay's gonna win it.
Every time
Listen,
there's been
this
a math
man's
section,
on
I've been
Christmas
looking at
tree
it, I'm
and he's
like,
gonna
yeah.
that's the highest
Like
score.
I can't, it's
You're
not
like-
in my head like him like home with his cat, like studying, like it's just not registering to me. I wish you the
Like
best,
Matt
but I know
Damon
you're
in
gonna
that
kill
movie.
it.
You're like Matt Damon in that one movie.
Who's Matt Damon?
You know Matt Damon?
Matt, you know what
He
that
solves the
is?
problem on the board.
Ben Affleck's boyfriend.
Talking about
Yeah.
Google. Yeah. My best friend's been Affleck.
Yeah, you don't say.
Time changers don't have to be street.
Very good, Jay.
Okay, answer the other question. Yeah.
And you guys did this same exact practice problem when we went over chapter 6. This is the slide from chapter 6
That's why I looked
a year
at it.
ago. Yeah. I didn't change the PowerPoint at all.
Yeah.
This is the chapter 6.
Nothing gets in.
All right, so in this question, what tells you that you should use the direct square law formula instead of the inverse?
Needed to maintain exposure to the IR. Read the question first, and then everything will tell you what to do.
It also asks for what's your new mass, and we have a change in distance, right?
So good.
Can we plug anything else into the direct square law formula?
Only the three.
So don't forget, write it first. Now you could plug in just MA, just time or mass, and distance. Any distance. Did you identify your D1, mass 1? And we're looking for mass 2, right? We start out looking strong, didn't flip.
I'll flip out.
Did we remember to square? Don't trust your brain. Go ahead and put it in the calculator, even if it's 2 plus 2. Did it look like that?
Oh yeah.
Do we do the same thing that we always do anytime we have a proportion?
E.
And not reduce the fraction? We always multiply across and divide what's left? Did we get anything other than 81?
Yes, I did something wrong.
But did we identify it because we wrote out all your steps?
Yeah.
Is there a way to check it?
Plug it in and then see if it's equal.
Yes.
Remember that.
So if we plugged 81 for x after we squared, and then we reduced the fractions, divided the top by the bottom, both of these should be the same number. Now, we can check it a second way. which direction did we change distance? Did we get further or closer? Further away. So what should we have expected to need to do to our mass? Increased it, right? So if you got a number smaller than 25,
You done goofed.
the concept says that you are wrong. So you can immediately eliminate any answers that are lower than 25. Does that make sense? The only ones that are higher could be a possibility.
Man, if you write the formula wrong, your answer's gonna be so bad.
You gotta rationalize what your answer is.
Yeah.
Mm-hmm.
Oh my god.
That's why we're going to practice writing that formula. That's why I want you guys to keep writing it over and over again. So that way you have no doubt that you wrote the formula correctly.
His answer's so wrong.
Did you start with the wrong
I
formula?
started with the wrong formula, and I was like, that's not anything. That's a little slide. I got it.
Okay. Are you guys ready for a break? You want? Okay.